Hello, in this Vulkan video I am going to show you how to implement fixed functions. So fixed functions, essentially what it allows you to do is set a bunch of stuff with Vulkan. It requires you to be explicit. I think you probably noticed by now if you've been following the videos, literally about everything. You need to specify pretty much everything that you want to be done. In all the graphics APIs, stuff like multi-sampling and color blending, that sort of stuff, they would have some sort of default state that it would just use, and you could override it if you wanted to at a later date. That's not the case with Vulkan. You literally need to specify virtually everything. So let's just get down to it. First of all, scroll down to the start of your class where we started, or where we've created multiple variables, and we need a pipeline layout. So vk pipeline layout, and I'm going to name it pipeline layout with an underscore at the start. And now what we're going to do is go to the cleanup method, and we'll just clean this up so it's just done and dusted. We're going to say vk destroy pipeline layout, specify the device, and then we specify the pipeline layout object, and finally some optional callbacks. I mean, I say they're optional because you can put null pointer there to prevent the callback from occurring. The parameter is not optional. So yeah, that's really it. And now what we're going to do is scroll down to the point where we get to the create graphics pipeline method. So almost there now. It should be, yeah, here we go. And after we set the shader stages, this is where all the work's gonna go down. So we're gonna implement the fixed functions. So we're gonna specify that first of all, this is what we're gonna do, that there's currently no vertex data. We'll circle back to this later, because we're not drawing anything currently. We will be. For now, we'll specify that there's nothing happening to prevent any errors. So I'm gonna put vk pipeline vertex input state create info. I'm going to call it vertex input info, and we're going to say vertex input info dot s type equals vk underscore structure underscore type underscore pipeline underscore vertex underscore input, there we go, underscore input underscore state underscore create info. And now we're just gonna set the vertex binding description count to 0 and the vertex attribute description count to 0 as well. So I'm gonna say vertex input info dot vertex, the binding description count equals 0. We'll copy and paste that because it's pretty similar. It's going to change this to vertex attribute description count. Okay, so next what we're going to do is create an input assembly. So this allows us to set what type of geometry is to be drawn and whether or not we're going to do a primitive restart is to be enabled, which is useful for stuff like triangle strips. We'll be setting that to false. And we're going to put vk pipeline vertex pipeline vertex assembly. One second. Pipeline. Yeah, input assembly state create info. Call it input assembly. Put some curly braces. Don't know where the square bracket came from then. And now let's just set this. Not too hard. I'm gonna put input assembly dot s type equals vk underscore structure underscore type underscore pipeline underscore input underscore assembly create info. and we're gonna set the topology now. So basically the way he draws it, we're gonna put input assembly dot topology equals vk underscore primitive underscore topology. So these are the 5 different, topology, not 5, these are the main different ones. There's line list with adjacency, line strip, etc, etc. The one we are interested in is triangle list, and this basically draw the triangle from every 3 vertices without reusing. Okay, so there we go, and now we're just going to set the primitive restart enable to false. So input assembly dot primitive restart equals vk underscore false. There we go. And now what we're going to do is set the viewport, and the viewport describes basically the region of the frame buffer that the output will be rendered to, like the triangle, your game, etc. This will almost always be from 0, 0 to screen width and screen height, which is going to be the case for us. So vk viewport view, call it viewport, put curly braces here, and we're going to put viewport.x equals 0.0f, viewport.y equals 0.0f, and we're going to set the width of it. So viewport.width equals, I'm going to cast it to a float, so float underscore swap chain extent, which we already created before, dot width, and I think you can guess we're going to do the same for the height as well. And height, and we just need to set a min and max depth for the viewport as well. So I'm going to say viewport dot min depth equals 0.0f, and viewport dot max depth equals 0.0f. No, 0.0, 1.0f. My bad. My bad, indeed. And now what we're going to do is set the scissor. So the scissor is basically how much of the frame buffer is to essentially be drawn, and we're going to be drawing all of it. So we're going to put vk rect 2d, call this scissor, curly braces, semicolon. I'm going to put scissor dot offset equals curly braces 0.0, so no offset. We're going to be drawing all of it, and we set the scissor extent to be the swap chain extent. Okay, so now that we've done that, the next stage is we need to create a viewport state, and this is used to combine the viewport and the scissor rectangle. So essentially the viewport is the whole, essentially the screen, or like the window, or like what's to be drawn, and scissor is how much of it is going to be drawn. So I'm going to put vk pipeline viewport state create info viewport state, and we're going to set the s type. So viewport state dot s type equals vk underscore structure underscore type underscore pipeline underscore viewport underscore state underscore create underscore info, and we're going to set a viewport count to 1. So viewport state dot viewport count equals 1, and we're going to set the actual viewport to the viewport that we created above. So viewport state dot view p viewport equals a reference to the viewport. There we go. And we're going to set the scissor count. On some graphics cards you can set multiple scissor systems. We're just going to be dealing with 1. Scissor count equals 1. Viewport state.p scissors, and we just pass a reference to the actual scissor itself. Okay, so now what we're going to be doing is creating and setting up the rasterizer, and the rasterizer basically takes the geometry that is shaped by the vertices. So in once we've done this, it'll be a triangle, it could be anything, and it takes it from the vertex shader, turns it into, fragments that are going to be colored, in the fragment shader, which we've created before. And it also performs depth testing, face culling, scissor test, and it can be configured to output fragments that basically fill entire polygons or just the edges, and there's also wireframe rendering as well. That's basically what that is. Okay, so to create it, just put a VK pipeline rasterization state create info having difficulty spelling today. Rasterizer. Okay. Oh, sorry for that. I'm going to put rasterizer dot s type equals vk underscore structure underscore type underscore pipeline underscore rasterization underscore state underscore create info. And we're going to set the depth clamp to false. So rasterizer dot depth clamp enable equals vk underscore false. And now we're going to set the rasterizer discard to also false. So rasterizer dot rasterizer discard enable equals vk underscore false. And we're going to set the polygon mode now. So rasterizer dot polygon mode equals vk underscore polygon mode fill. So it just fills, the polygons that it's going to be drawing. I'm going to set rasterizer dot line width equals 1.0f. and put rasterizer dot cull mode equals vk underscore cull underscore mode underscore back bit. And then we're going to set the front face. So rasterizer dot front face equals vk underscore front underscore face clockwise. And we're going to say rasterizer dot depth bias enable and we're going to set that to false underscore false, like so. Okie dokie. So there's a fair bit that we've done, and we're getting there now, not far off from the end. Now we're going to be setting the multi-sampling, and the multi-sampling is a process for reducing aliasing at the edges of rasterized primitives. Basically, that staircase jagged effect you get. For now, I'm going to disable it, but we'll check back on it later. But again, we need to be explicit about literally everything. So VK pipeline multi-sample create info we call it multi-sampling curly braces semicolon, and we're going to say multi-sampling dot s type equals vk underscore structure underscore type underscore pipeline underscore multi sample state create info, and for multi-sampling dot sample shading enable equals vk underscore false. And I'm going to say multi-sampling dot rasterization samples equals vk underscore sample underscore count underscore 1 underscore bit. Okie dokie. So now what we're going to be doing is the color blending stuff. First we'll create a color blend attachment, and then we'll do the color blending. So what is this? Essentially, after a fragment shader has returned a color, it needs to be combined with the color that is already in the frame buffer, and that's what's known as color blending. There's two ways of doing it. Mix the old and new value to produce a final color, which is what we'll be doing. And the second method is combining the old and the new value using a bitwise operation. Basically, to use it, you just set the logic op enable to vk true, which I'll show you in a second. So you will just set it to false, you can set it to true. VK pipeline color blend attachment state color blend attachment curly braces semicolon, and now we'll just do the bit masks. Okay, so I'm going to say color blend attachment dot color right mask equals vk underscore color underscore component rbit, and we're going to put a vertical bar to OR it, and we're going to do RGB like so, and then we need to do the alpha one as well. We can get rid of that final vertical bar RGBA. There we go. Okay, so now what we're going to do is set the blend enable to false. Color blend attachment dot blend enable equals vk underscore false, and we're actually going to implement the color blending now. So I'm going to say vk pipeline color blend state create info color blending, and let's say color blending dot s type equals vk underscore structure underscore type underscore pipeline underscore color underscore blend underscore state create info. Next, we'll just set the logic op enable to false. Color blending dot logic op enable equals vk underscore false, and this is what I was referring to earlier. If you wanted option 2 of the color blending, then you will set this to vk underscore true. And we're going to set the logic op now. So color blending dot logic op equals vk underscore logic op copy, and I'm going to set the attachment count just 1 for now. Color blending dot attachment count equals 1, and I'm going to set the attachments to the color blend attachment that we created. So color blending dot p attachments equals a reference to color blend attachment, and now we just need to set the value. So color blending dot blend constants 0 going to be equal to 0.0f, and we'll set them all to 0.0f, and there's 4 of them in total, so 0, 1, 2, and 3. And next, so we've done the color blending. So what we're going to do now is create a pipeline layout info, and this is used for altering the behavior of shaders without having to recreate them. Again, it's something we're going to circle back to, but it's good to just have it there. And we're going to put vk pipeline layout create info, call it pipeline layout info curly braces. We are almost there now, a few lines of code left. We're going to put pipeline layout info dot s type, set the s type to vk underscore structure underscore type underscore pipeline underscore layout underscore create info, and I'm going to set the layout count to 0. So pipeline layout info dot set layout count equals 0, pipeline layout info dot push constant range count, set that to 0 as well. And now we're just going to actually create the pipeline layout. We're going to do in an if statement. If it fails, we'll throw an error. So we'll say if vk create pipeline layout, and we specify the device, specify a reference to the pipeline layout info, and then some callbacks. We'll put no pointer so we don't have any callbacks. Then we specify the pipeline layout, so reference to underscore pipeline layout, which we created right at the start of the video. And if this doesn't equal to vk underscore success, then we'll throw an error. std colon colon throw std runtime error failed to create pipeline layout, and we should be done. Let's give it a run and let's see what we get. So it's just loading all the extensions, checking that with the validation layer, and let's have a look. That's fine. We've gained that validation error before for the anisotropic filtering, and again, that's not a problem. Everything else is all good. Again, we don't have anything drawn yet, but that was it. We just implemented fixed functions. So if you have any questions, feel free to pop me a message, or better yet, post in the pop me a message on Discord, but post in the Discord group on the Vulkan channel. There's over 4,700 members now, growing every single day. We'll probably hit 5,000 by the end of next week, and maybe even this week, to see if we can get it over there. There's a link in the description for that. There's a link in the description to the GitHub page, which has all the source code for every video, plus working projects that you can just out of the box run. And that's it. Thanks for watching, and I'll see you in the next Vulkan video.